crazy. So beautiful is not the term that's on the tip of my tongue. Particular moment, but by and large. Hi everybody, thanks a lot for coming. It's nice to see a lot of people back from last time. Where do I want to start? I guess let's just do a show of hands. Who was here last month, I guess? Okay, so it's kind of 50-50. I realized that just before walking over here, I should do a quick synopsis because today is kind of part 2 from what we talked about last month. So for those who weren't here, don't sweat it. It's not like you're going to be lost. I just want to cover what we talked about last month. The take-home points were the world over the last 20 to 50 years has warmed by about 1 degree on average. That's the whole Earth heating up by 1 degree. And by extension, the thing that's causing that warming is greenhouse gas emissions from humans, fossil fuel combustion, agriculture, and a couple of other sources. That's, in a nutshell, what we talked about and had a really nice discussion last week. And so today's talk is the second part of that, which is this theme, what will the future climate look like, knowing we're on this trajectory of warming and increased greenhouse gas emissions. I quickly realized I bit off more than I can chew on this talk. So we're going to carve it up into a couple different slices and convey some take-home messages surrounding this question. And this is actually, sorry, before I do, I want to give a quick thank you, well, to people who aren't here. There were 2 reporters kind enough to write articles about these events in the Lake Report and the Local, Mike Balsam and Keir Simone. I think that becomes, and for everybody for participating as well, I think participating in this type of science-based event is very, very important for community and for sort of climate governance. Because although, as we talked about last month, the idea that climate change is happening is becoming more common, this just came out in The Guardian last week, showing that concern about climate change is starting to shrink, despite the fact that we have a lot of evidence that it's actually getting worse. So this idea that, acceptance of climate change is a big issue, is a done deal, is not really borne out by the information that comes from types of surveys. This was, just to give you some idea out of that article, fewer than half of those questioned in a new survey believe climate change poses a very serious threat. So this, I guess what I'm getting at, thank you all for coming, because I think conveying the science of climate change remains critically important across the world, quite frankly. Okay, so I'll start with a question. What do you think the future climate is going to look like? You can talk about this in just the broadest terms. What have you seen in the news? What direction do you think we're going in? Does anybody got? Yeah?
We're going to have a lot more storms and irregular weather.
Irregular weather and more storms? Yeah, absolutely. Storms in all different forms, hurricanes, thunderstorms, whatever the case may be. More weird stuff generally. Anybody else? Warmer. That's definitely one of the common themes. Warmer, more extreme heat. Yeah, please.
Reduction of water in our lakes.
Yeah, reduce lakes. Reduce water levels, reduce precipitation and inputs into lakes. More sort of drought-like conditions.
The shoreline's increasing.
That's
the coastal shorelines.
That's a very good point. That's a complicated one too, because we see shoreline increasing in certain points, and we'll see in a bit shorelines receding more. If you live along the ocean and seaside. So another highly dynamic coastlines. Yeah, these are all great examples. You can kind of go off the top. Forest fires, crop failures, whatever the case may be. There seems to be no shortage of climate change news relating this point, that the climate is shifting and what's it going to look like. Some of these are general in nature. They just talk about a looming climate crisis, just we know the climate is shifting. But other ones, other science articles or media reports, kind of paint a little bit more of a specific picture of a certain corner of the climate system that's going to change. So for example, this is from the magazine Science about a year ago. The United Nations confronts implausibly hot forecasts of future warming. So a very specific example of how the climate's going to shift. Again, on that idea of heating of the world, that's probably one future climate scenario we hear a lot of. This was also from the New York Times just about a month ago or so. We know that the world is getting warmer. It's just a matter of how much at this point. And then there's the flip side of this that was alluded to. There's the temperature part of climate. And then what kind of gets dragged along with the temperature part are changes in Earth's water cycle. And those can take a couple of different forms that we'll talk about today. So for example, the one that's most commonly associated with warmer temperatures is more drought, warmer and drier. But the hydrological, the water part is a little bit, it kind of confuses a lot of folks, because what you tend to see that comes along with droughts are floods as well. So you get kind of two parts of the equation that for a lot of individuals is kind of hard to wrap your head around. How can it be one and the opposite at the same time? But in any case, that's where we're seeing that multiple dimensions of climate change get mushed together in media reports. So for example, here we're talking about heat waves, droughts, wildfires, and floods. All of these things are coming our way. And it can kind of be a little bit, I find a little bit overwhelming to try and disentangle all these things when you're just hearing everything's going to change and everything's getting worse. This is more from the Canadian example that points to just that, the uncertainty of what the future climate's going to look like. So for example, was anybody aware of, this is kind of new to me, there's a tremendous floods going on in the Sunshine Coast right now. Severe droughts are tormenting BC after floods. So we're sort of seeing floods and droughts kind of changing off from one another within the course of weeks, which is very unusual. And then they all kind of, again, get mushed together. Storms, floods, increased temperatures, all of these things are happening at once. So it can be a little bit tricky to make sense of what are the scientific predictions about what the future is going to look like. And that's what we're going to talk about today as we march through, much like last month, these 6 points that we're going to talk about today. A quick background on the Intergovernmental Panel on Climate Change. That's the scientific body we'll be talking about today. What climate change predictions depend on. Then we'll talk about predictions of temperature, predictions of precipitation, some information on what the likely scenarios here in Niagara-on-the-Lake will look like based on the best case evidence. And finally, we're going to wrap with predictions on the impacts of climate change. This is where I bit off more than I can chew. There's a whole study on that. We probably could have spent a whole day on that. But we'll sort of march through these. Each of these will, again, take about 5 minutes to get through, and ultimately emerging at our last point. This one takes a little longer, just because a lot of this stuff depends on it. Okay, I realized that last month, I was talking a whole bunch about the IPCC, the Intergovernmental Panel on Climate Change. Just a quick show of hands. Who's heard of the IPCC before, those letters? Yeah, kind of 50-50. And I'm sorry about that. I assumed, never assumed. We're going to be looking at the science that comes out of the Intergovernmental Panel on Climate Change. So I thought it appropriate just to give us a little snippet of a background of what I'm talking about when I mention the IPCC. So what the IPCC is, in short, is the global scientific organization that collects, interprets, and analyzes all of the climate science or the climate data that exists out there in the world. Their mandate is to put together a comprehensive picture of how the climate is changing and what those changes are going to mean for everyday life or other parts of our world. I just put this up there. The IPCC comes out, it's been around for, I guess, just about 30 years now. Broadly, kind of comes out of this important environmental, what would you call it? International conference in 1992, which was the Earth Summit. Gordon, we were just talking about the Earth Summit. Have people heard of the Earth Summit before? Quick show. Yeah, this is kind of held up as like the most important environmental policy setting meeting ever in the world. And it took place in Rio in 1992. All the leaders were there, like Bush is talking. It was very influential. And it's influential because, it's getting harder and harder to get people to agree on policy items. But what comes out of the Rio meeting are 4 things that kind of set the stage for sustainable management of our environment, or just generally environmental conservation. Prior to the Rio meeting, a lot of these important policy things didn't exist in a global way, and they all come together at Rio. There's a couple of them. Agenda 21 is something that Gordon Young worked on. It sort of puts sustainable development into policy frameworks for the first time. So it kind of elevates environmental conservation or sustainable development as a policy agenda, kind of for the first time ever. There's this thing called forest principles. That's what we use globally to assess sustainable forest management. So that shows up for the first time. This guy here, which we'll talk about next month, the Convention on Biological Diversity comes out of this meeting. That's basically the thing we use to set biodiversity targets globally. Prior to this meeting, that remarkably didn't exist at all. And this one here, which is the United Nations Framework Convention on Climate Change, or the UNFCCC, as it's most commonly referred to in the sort of policy language. And this is the international framework that we use to get countries to work together to set and meet climate change related targets. I'll come back to that in a second. Well, let me do it right now. So the UNFCCC, the United Nations Framework Convention on Climate Change, probably the first time much of the world ever heard about this organization was Kyoto. So if you remember the Kyoto Protocol, which was like our first set of greenhouse gas targets, that was a direct product, or the first major outcome of the UNFCCC. That's what they set up to do, and that's what they did for the first time, wow, way back in 1997. Now, the UNFCCC, so I'm going to try and avoid using acronyms. They drive me bonkers, but sometimes it just makes life easier. This United Nations Framework Convention on Climate Change holds meetings annually. And these meetings often show up in the news. Usually if you see big climate protests, they're usually centered on these UNFCCC meetings. Some get more attention than others because in some meetings we actually set new targets and then usually promptly miss them, but we set them anyway. So for example, if you heard about the Paris Accord, or the Paris Accord and the Paris targets, that was from the UNFCCC meeting in 2015. And that's our current set of targets that we've kind of agreed to. But again, some kind of fly under the radar. Last year, the UNFCCC meeting was in Glasgow, and kind of sometimes not much happens at these things. It's the ones where the new targets come out that tend to get a lot of attention. Okay, so where I'm going with this is this. The Intergovernmental Panel on Climate Change, the science we'll actually talk about today, is kind of piggybacked on top of this group. I'll come back to this in a second. The IPCC does the science that then sort of streams into that United Nations framework. So when we set targets and stuff like that, it's coming from the science that the IPCC does. So it's the global science fitting in or filing into the global policy. So the IPCC kind of starts around the same time. This is just what I want to point out. What the IPCC is tasked with is summarizing all the climate science approximately once every 5 years. And they've done that for about the last 30 years or so. This is what we're going to talk about this today, is sort of right here. So the IPCC kind of does some things, right? They do the protocol assessments. They do a lot of documents in between. This is where we're at present day. Just last year and this year, the IPCC released their latest report, which they call that the assessment reports, the assessment cycle. That's like the best state of climate science that exists today. And that's what we're gonna sort of fill in some of the gaps with. I asked these things are wild. Has anybody, I know I asked last week, has anyone leafed through one of these reports before? Yeah. Gordon has.
Today's student in the front row.
Yeah. What I would say, this one was so big I couldn't even download it. It depends which one you look at. They're usually like 300 pages or more, and they're brutally dense. They're just so much information in there. It can be a little bit tricky and daunting. But we're going to boil this down into the most sort of important take-home messages. So the IPCC reports now, they're kind of come out in three-parters. There's this one, which will make use of the physical science basis. That's like the hardcore climate science kind of stuff. There's this one, which is called Mitigation of Climate Change. That's a humongous report outlining management strategies to prevent climate change from getting worse. And lastly, there's a whole section on impacts and adaptation, a whole set of predictions about how that physical change in the Earth is going to actually influence the things that humans most care about, quite frankly. We're going to boil that whole thing down into about 2 slides. So we're going to focus on the first one, a bunch of the stuff that comes out of that physical science basis. That's the one where we make predictions about what the future climate is really going to look like through all their different analyses. Okay, so that's the quick thought on the IPCC, just to get us on the same page. The next point is this idea of what do climate predictions depend on? And this is a really critical part of what the IPCC does. So when we're trying to figure out what the future climate's going to look like, we're doing just that, predicting the future, which is never easy. Now the IPCC, and what we'll talk about today, discusses the future climate kind of in 3 chunks. They talk about short-term climate change. That's what's going to happen, we think, over the next 20 years through to 2040. They talk about medium-term change, which gets us pretty much the period of 2040 to 2060. And they talk about long-term change, which is the period from 2080 to the end of this century. I gotta tell you, the one thing about having kids, it really changes your perception of time. I used to think this was so outlandishly far that I'm like, well, whatever, doesn't matter. But this would probably represent for myself, my children's children. So it's not as outrageously of a long run out as we think. It's really quite soon, I guess. Okay, so for that reason, because we're sort of like predicting out into the future, I just want to highlight something. These predictions about what climate change is going to look like necessitate or always have 2 things. One, they always entail some uncertainty, just by nature. And that's the thing that makes the IPCC reports so hard to read, is they pack it with so much uncertainty. Scientifically, it's important. It's very hard to read. And 2, so this uncertainty or predictions, they always depend on what we think is going to happen into the future. And so for these reasons, we have, let me summarize this, 3 timescales we'll talk about today. And we're going to deal with this idea about the uncertainty and how we think the future climate's going to look. Okay, now, there's a lot of uncertainty about what the future's going to look like, particularly as it pertains to what the future climate's going to look like. Now, leading off from what we talked about last week, this idea that climate change is very much propelled by human greenhouse gas emissions. So by extension, if we're going to predict climate change into the future, these predictions are going to depend on what we think greenhouse gas emissions are going to look like into the future. Now this, how we think greenhouse gas emissions are going to change, kind of depends on a bunch of stuff. Laws, regulations, human behavior. We talked about this. Something like how ecosystems are going to respond to climate change. If all the forests start to burn all of a sudden, that's a critically important determinant of how greenhouse gas emissions are going to look. So we got a bunch of stuff. Now, what the IPCC does, first and foremost, when we're saying what's the future going to look like, this is what we set out. The IPCC sets out 5 different greenhouse gas emissions scenarios. That is, we have 5 different scenarios that greenhouse gas emissions can look like, and we call these things, they just changed the name, shared socioeconomic pathways. This is the fancy term, or SSPs, sorry, I'm getting into acronym land. SSPs, we have 5 of them, and I'll show them in graphical form in just a second. Well, actually, why don't I just do that right now? So this is a graph that underpins all of these IPCC predictions that we'll show in a second. So we use 5 different emissions scenarios or shared socioeconomic pathways. And these are encapsulated pretty simply in this graph. What we have on the y-axis here are total carbon dioxide emission rates. Think of it, just total greenhouse gas emissions going from low emissions at 0 up to high annual emissions up at about 140 gigatons, condensed matter, low to high. And these emissions are going to change from 2015 predicted out into the year 2100, depending on what we think is going to happen in the future. These SSPs, they're numbered here, 1, 2, 3, 4, 1, 1, oh God, why do they do this? 1, 2, 3, and 5. Those are the ones we'll use. Don't worry about that too much. This little number, don't let this decimal place throw you off. You kind of think you're inclined to think this means temperature, but it just means like how much climate change is going to happen in the future. So this is kind of what it looks like. Down here, if you focus on these blue lines, what these blue lines represent, these SSP ones, what these look like is this. We have greenhouse gas emissions that stay steady up until present day. And then, for some political, socioeconomic, behavioral reasons, whatever those might look like, greenhouse gas emissions start to drop, basically as recently as about the year 2020 to 2030. So what these mean is that we have policies in place that limit greenhouse gas emissions almost magically. And by extension, we'll see in a second, by extension, these then limit climate change. That's the first scenario. We have some kind of moderate scenarios in there where greenhouse gases, again, are on this trajectory. And then we've got 2 options. One is that they continue to increase for about the next 20 to 30 years and then start to drop off. Or this guy, which represents more of a linear increase in greenhouse gas emissions. These are, I guess, what we would call our sort of moderate scenarios. And the doomsday, way up here, which is this dark red line, and what that dark red line represents is a greenhouse gas emission scenario where it's kind of like we stop trying to eliminate or reduce greenhouse gases, but instead we continue on trajectories that continue to pump more and more greenhouse gases into the atmosphere. So I'll be coming back to this a little bit because what you think about the future climate kind of depends which one of these you choose in a way, or which one we think is most realistic. So this is kind of the nice summary of where to start. Quick question. Does anyone want to guess which one we're on right now? Which current SSP the most recent evidence suggests we're moving towards? 5? Rob, you thinking this one here?
Yeah.
Good guess. Anybody else?
The one right under it.
Yeah,
You would think this one has
Yeah.
the linear increase? Yeah. They're both probably, I think we're still sort of in this chunk, so they're kind of still overlapping. My understanding is we're sort of heading towards this one. So, Rob, you're quite right. That there's been no indication that we've actually, to use COVID terms, sort of bended that curve down. So this looks nightmarish. See, it kind of is. But it's also very realistic. I would actually add to this that these blue ones down here, some of the climate scientists that I work with, they've actually stopped using that one altogether because it's so just totally implausible that that's going to happen. So, at the very least, I think we're somewhere here.
What's the measurement of the GT? Is that gigatons or?
Mm-hmm. Yeah, gigatons of CO2 per year. This gets into I got a friend who calls it the illions problem. It's like billions or millions of tons. It gets kind of incomprehensible, really. That's what I was saying, don't worry too much. But yes, it's gigatons of CO2 per year. Yeah.
And why does the disaster one start to go down? Is that where
This
we
one here?
start dying off?
I think you might be right. That's a very good point. I don't know. Yeah, maybe just people are dying. Yeah.
Fewer people towards the end of the century.
I think you're right. Probably also this could reflect, we're talking about CO2 emissions, like greenhouse gas emissions. What this could mean is we've also like sucked up all the oil and just don't have any left to use. Or at least to sort of continue to increase at the same rate. So it can mean a lot of different things. Mass death might be quite conceivably on that
I
list.
think this is depressing.
Yeah, it's a bummer, for sure. Okay, so these are our scenarios. We're going to use these to then flip to the next set, which is what are our predictions of temperature? This is the place to start, because as we'll see in a second, temperature is a little easier to predict than precipitation, because it's just more closely matched with greenhouse gases. And again, what we think about the future of temperature then is going to depend on which of these greenhouse gas pathways we're actually on. So this is another figure from these reports. What we're looking at here is global increases in temperature relative to a baseline from about a couple hundred years ago, prior to industrial times. And these increases go from a 0 degree increase up to a potential 5 degree increase. That's just the world getting warmer by this amount relative to the past. From 1950 through to the end of the century, 2100. So the first part is this black line with the gray shading. What this represents, going back to last month, is the warming that the Earth has experienced since about 1950. Over the last 7 years or so, we know that the Earth has gone up on average by 1 degree across the entire planet. That's like heating the whole globe up by a degree, which is not easy to do. So this part we know, and that takes us to about 2015, and now we're getting into prediction territory, and this is where those pathways kind of matter. So if we take our I'm going to use the term pie in the sky kind of scenario, where we basically think we're just going to chop all emissions and it's going to go down to nothing. Actually, the trajectory of the Earth warming looks not bad. What these send us out to is an increase of about, just shy of 2 degrees out to the end of this century. What I want to point out, though, is even if we chop all emissions basically yesterday, between today and for the next sort of couple of years, the world is still going to warm a little bit. And that's because we've already pumped those greenhouse gases into the atmosphere, and they're still having their impact on the temperatures that we experience. So, why I want to point that out is because you may see this in the news. You may see this term called, this idea that we've committed ourselves to global warming already, no matter what we do. That's what that point kind of refers to. This committed warming, that even if we stop emitting CO2 completely, it's still going to go up like another half degree or so. We can get into the moderate scenario. This is the temperature that you predict down at the end of the 21st, what century? The year 2100 in those sort of more moderate scenarios. And then in our more concerning scenarios, these are the temperature increases that we start to predict in these much more aggressive scenarios where CO2 emission rates just keep going up and up and up and up, starting to hover around 5 degrees. So, what I just want to highlight here is a couple things. One, what we think is going to happen in the future depends on what we think is going to happen with greenhouse gases. We have 5 scenarios. They kind of start to differentiate. And here, we're talking about the whole world warming up. This is the globe en masse. So for that reason, we can kind of start to break these predictions down in a little bit more detail and start to sort of understand where we go with these. So let's kind of break this down and think about these different predictions and what they're predicting in the near, medium, or long term. So we can start with the near term. that's highlighted by this gray box here. So we're looking at, again, global temperature increases from 1950 to 2100. And the near term, as per the IPCC, is kind of this chunk here, just about the year 2050. And depending which one of these actually plays out, by the middle of the century, this is broadly what you predict. All of these lines, you can kind of tell they're still kind of bunched up together here. If you kind of draw a line, they're all still just at about the same level. So in the short term, or the near term, which is about 20 years or so from now, whatever scenario you pick, in a way, I'm not going to say it doesn't matter, but the scenarios are still lumped together. So by the year 2050, we're expecting to see just about 1.5 degrees of warming across the world at large. When you start to go out into the medium term, that's where those lines start to branch off from one another. And that's where these scenarios really make a difference. So for example, if we go to the medium term, which is 2014 to 2060, this is what you start to predict. And this is where you get a sense of the importance of actually minimizing greenhouse gas emissions. It's sort of that medium, like a little bit longer term prediction. So in this case scenario, our cut everything greenhouse gas emissions kind of stay stable. The temperature line just levels out. But in these more aggressive greenhouse gas emission predictions, that's where you start to see the real difference happening. For example, if we continue on this trajectory of ramping up greenhouse gas emissions, between 2041 and 2060, so that sort of 2050 period, then you start to predict like a 2.5 degree increase for the globe worldwide, which is, about twice as much as the other scenarios. Okay, and then this kind of running out of these greenhouse gas emission scenarios kind of continues from there. So for example, if we move to the long term and we're predicting how the world is going to heat up between the year 2080 and 2100, that's sort of highlighted in this gray bar here, then the predictions are starting to diverge a lot, sort of giving us a sense how important it would be to cut greenhouse gas emissions. For example, for these guys, we stay steady at that 1 degree of warming. In some cases, models, our predictions would say the world might actually cool. That's conceivable. At the higher end, our ramp up greenhouse gas emissions continuously. Then by the end of this century, we start to predict that the world as a unit heats up by upwards of 4.5 degrees Celsius. And again, I just want to highlight a couple things. This is the whole world, the average temperature across the world heating up by this. And this number, pretty obviously, is about 4 times this amount. So depending which one of these actually plays out, we could be in like a pretty reasonable scenario, still warming, but reasonable, or a scenario where the world warms by 4 times as much. So again, our predictions critically depend on which one of these play out. Any questions about that graph? Please, if you have any questions, fire away. Is that one okay? We could. Cool. Okay, I'm just going to highlight. What's that?
I said it frightens me because it's overwhelming to think what we're doing what we'll be doing to the next generations. Like you have small children, I have small grandkids.
Yeah. Yeah, it certainly is. Sorry, I don't mean to freak you out further. The maps make it look a little more striking, quite frankly. We'll get to those in just a second. Mm-hmm. But you're right. I'll come back to this point when we talk about impacts. This emerging field of climate change anxiety in the psychology literature, which I'll come to in a second. Yeah, did you have a question?
You mentioned that if we stayed there at the 1.9%, it could actually start to cool. I've read somewhere that, in fact, if it weren't for greenhouse emissions, the Earth is in a cooling period.
Yeah.
Right?
Yeah.
Yeah, we talked about that last month as well. There was this brief period sort of prior to the year 1900 that was actually showing the cooling trajectory. And then kind of along comes like the Industrial Revolution and especially what they call the Great Acceleration, which is post-World War II period, and that's where greenhouse gases just skyrocket. But you're right, there's evidence from ice cores, tree rings, those kinds of things that shows the world was actually cooling. This was a thing, right? There was like the global cooling concern in school for a while, right?
Yeah.
The mini ice. Yeah. That's very much what that's based on.
Which raises a question for me, and I've never been able to find out. We've had like 3 ice ages,
Yeah.
and so obviously there's been a period of warming.
Yeah.
What causes those?
Yeah, again, we kind of touched on this last month as well, but you're right. When the Earth is warming, the recent warming we've seen is greenhouse gas emissions. The science is pretty clear. When the Earth has fluctuated between these ice ages, we know that they come and go on cycles of tens of thousands of years, upwards to hundreds of thousands of years. And we were talking about this over email. That has to do, the Earth's position to the sun changes over very long periods of time. The tilt can turn, the axis can turn, all these things can change. And those are the things that trigger ice ages, by and large, that sort of, that ignite an ice age, I guess. So yeah, there's natural causes like that, and then greenhouse gas emissions, which are the more recent things.
So do we know when the next ice age is coming?
Yeah, that's a good question. Well, you could probably get, I don't know, maybe 100,000 years or so. Yeah, not fast enough, I guess.
Won't be here.
Yeah, I don't think humans will be here necessarily. Okay, so that graph that I just showed a second, this is kind of summed up back to our report, just to give you a sense of what some of the language in these reports look like and how some of the conclusions emerge from them. This is a big conclusion, and I'll just read it off. This is one of the big findings. Global surface temperature will continue to increase at least until the mid-century under all emission scenarios. It's going to go up. Global warming of 1.5 degrees Celsius and 2 degrees Celsius will be exceeded in the 21st century unless deep reductions in CO2 and greenhouse gases occur. That's one of the big findings that the IPCC conveys to policymakers. The temperature is going to go up. We're kind of committed to that. But we still have some control over greenhouse gas emission scenarios to kind of modulate what it's going to look like at the end of the 21st century. But I just want to highlight this, and let's get to some maps here. Just want to check the time as well. That's the world, right? That's the whole globe that we're talking about in those graphs, heating up by 1 or 4 degrees Celsius. That's like a really kind of impersonal way to think about it, I guess, because I don't think you really personally experience the world heating up. So we can kind of like chop this graph up into a little bit more, kind of put it on a globe and see, what different parts of the world will look like under these different scenarios. So let's assume this one. Let's assume that at the year 2100, this is our emissions scenario. So at the end of the year 2100, we're left with 1.5 degrees Celsius of warming across the globe. What the IPCC and what these predictions then do is we're able to sort of map that. That warming's felt unequally, kind of differs depending what part of the world you're on. And we're going to see a bunch of globes, a bunch of maps rather, that are colored according to temperature increases or predicted temperature increases. So the lighter color reds are going to be places that really don't warm that much. And the darker color reds are going to be the places that warm the most, upwards of a predicted like 7 degrees Celsius. So first of all, let's assume this one. In the best case scenario, this is our prediction of what the world is probably going to look like at the end of this century. So in a funny way, you'll come to think this isn't that bad. We see like a lot of parts of the world that are still experiencing relatively small amounts of warming. But some parts, especially the Arctic, this is a continuous theme about predictions that the Arctic heats up really fast. The Arctic sort of warming on the order of like 4 degrees Celsius, which is quite problematic for the climate system. Okay, so that's the best case scenario. That's what the world prospectively looks like in terms of temperature warming. Let's assume this one here. If we assume that the world is going to increase or rather, our greenhouse gas emissions are going to go up like in a middle kind of level. We then predict the world's going to warm by 2 degrees at the end of the century. Then the world looks like this, where you start to see, again, the Arctic really starts to come out in these maps under more serious greenhouse gas emissions and climate change scenarios. You're starting to see some parts of the world, like kind of north of Siberia, I guess, that are expressing upwards of a 6-degree warming trend by the end of this century. And then, in the more severe, let's assume that the world heats somewhere between these two. And that would mean that the world's going to warm up on average by 4 degrees Celsius. That's our kind of worst case scenario greenhouse gas emissions. And then the world looks much more concerning, and that these are what the mapped predictions of what the world's going to look like under that really serious greenhouse gas emissions trajectory. So you can start to see that deep, like the deeper reds start to, of course, become more pronounced. And that's because more and more of the world is heating up more and more. And there's 2 things. I'm going to zero in on some Niagara-on-the-Lake specific predictions in just a second. I think just to highlight 2 things. One, whatever scenario you paint, the Arctic is always kind of in the crosshairs of climate change. The Arctic shows a trajectory of warming much more than any other parts of the world, which becomes kind of concerning for polar bears, ice caps melting, those types of things. The other point is that the oceans actually stay a little bit cooler compared to land. It just takes more energy to heat up water as it does air, or land, sorry. I'll come back to these in just a second. So just as kind of a summary of what these IPCC reports then convey as a result of these findings, I'll just read it out. They write, it's virtually certain that the land surface will continue to warm more than the ocean. We have a pretty good idea about that. That global warming is really land warming in its most sort of common form. And it's virtually certain that the Arctic will continue to warm more than the global surface temperature, with high confidence that the Arctic's going to warm sort of twice as fast as everywhere else. So for northern communities in Canada, there's reason to think that no matter what greenhouse gas scenario you pick, those northern communities are kind of in not such a great place. And that's why you may come across sort of news articles that read something like this. The Arctic is warming 4 times faster than the rest of the planet. And that has to do with those maps we just looked at. That when we predict temperature, invariably it's the Arctic that heats up the fastest. Yeah.
But right now, the Arctic is so super cold that for them to go up 7 degrees, they might actually like that in terms of walking out the front doors.
Yeah.
So as they get warmer, that means that like our temperature spread around the world is going to sort of be less.
Yeah, that's a good, I totally see where you're going with that.
And then doesn't it follow that maybe once we're all sort of the same, things might slow down or even?
Okay, so there's like a couple of points there. Let me come back to these maps real quick, because you raise a couple of fantastic points. One, right, these are increases above what average temperatures already are. So the Arctic might warm by, say, 7 degrees, but it's still going to be cooler than, equatorial parts of the world. So thanks, I should have clarified that. The idea of whether or not this type of warming is good for people, I think we can categorically say it's not great for the natural world, like, polar bears, the Arctic ecosystem as it exists. We have good evidence that climate change is already fundamentally restructuring those and moving many species towards probably the brink of extinction. From a human perspective, harder to say. We've kind of seen that as, why am I blanking on it? As the Northwest Passage becomes ice-free for longer periods of time, we've seen increased commercial traffic, which is kind of oddly perverse benefit of climate change. Oil exploration is becoming more common in the Arctic. So, I don't know, to your point, whether or not it's good, I guess it kind of depends.
Well, it's just we're exploding with our population, and a lot of our country is uninhabitable.
Yeah.
And it'll become a place for maybe this exploding population to be.
Conceivable, yeah. It's an interesting talking point. Yeah, please, and then we'll, yeah.
You know, one of the concerns I have, the impact on people is as the permafrost melts, we
Yeah.
don't know what's in there. There's could be tons of viruses that are really detrimental to humans that are frozen in there as they become, you know, melted
Yeah.
and in our environment that can have a huge detrimental effect. In addition, because it is permafrost and I mean, right now, a lot of the transportation is done in the winter on the ice roads.
Right.
And as everything thaws and it's wet, I don't think it's going to be easy to get infrastructure in there for people to live in.
Yeah.
So I think there's a lot of negative things as
Yeah.
well as, you know, warming climate.
Yeah, you articulated that so nicely, and it's such an interesting question. Yeah, there's more complexities to it, right? As the Arctic warms, let's say our kind of Arctic and high Arctic, right? You know, especially kind of in the James Bay, Hudson Bay lowlands. You know, a lot of those communities and the infrastructure is predicated on permafrost. And as that starts to melt, we're starting to see it already in sort of Northwest Territories, Yukon. You know, buildings are starting to collapse, roads are effectively dissolving. So it's tricky to say. There's an argument for it, I guess. Probably the realities of a climate shifting this drastically, this fast, though, are going to be more detrimental than beneficial. Sorry, Tara, just 1 second. Yeah.
What happens to the water? It's melting.
That's what I was
Yeah.
just gonna
Water's
say.
got to go somewhere.
Yeah, that's right.
So I can't see how that's an advantage to anybody living near the ocean.
Living on a big, like, soggy
Sandbar.
bog. Yeah,
Islands in the
muskeg.
Pacific are disappearing.
Yeah.
Yeah.
Yeah. So it's an intriguing. Yeah, please.
How long ago was Al Gore's book out?
Yeah, I think that was in
30 years ago or so.
2003 or
And
something.
why did that not take off? Like, he was sort of an instigator on all of it happening.
Yeah. Yeah. I mean, that book was critically important for getting climate change on, you know, most certainly a media agenda.
Yes.
The translation to policy, kind of hard. I mean, it's hard to say. It didn't have the immediate political impact that it had in the media sphere, or
Yes.
sphere, let's say. Yeah.
That's too bad. It was lost.
Okay, so I'm just being conscientious of time as well. Okay, so those are the predictions of temperature. And again, the predictions of temperature, I just say, are a little bit more reliable, I guess we can say, because temperature has a more direct link to greenhouse gases and what greenhouse gases do. Predictions of precipitation, they do exist, we'll show you, and I'll allude to it a little later on. They're a little bit more fuzzy. They're a little bit harder to predict. It's kind of like, it's not just like predicting the rain, but it's a little bit more challenging, so we have more uncertainty surrounding precipitation. But we have some general trends that we can sort of evaluate kind of in the same way. This is the temperature graph that we just looked at. I'm just going to leave this up there because much like temperature, we can look at precipitation under basically 3 different greenhouse gas emission or global warming scenarios. So the first one is this. Let's assume the world warms by 1.5 degrees Celsius. Now, a little bit different. In the temperature maps that we saw, everything was a color red. There was no blue because there's no parts of the world that are cooling anymore. So everything's going a positive temperature. Precipitation's a bit different. When we talk about the percentage change in precipitation, some places, we'll see in a second, are predicted to become drier, and those will be the places in the maps that are colored brown. And some are actually predicted to become wetter, and those are the places that are going to be colored in blue colors. So let's assume this one, that we cut greenhouse gas emissions, we kind of limit it. This is what we think the world is going to look like in terms of changing precipitation patterns. There's a lot of places, especially equatorial regions, smack on the equator, that would suggest that they're going to get more precipitation over time. The Arctic, falls into this category as well. Then there's other places that look like they're going to be drier, even under relatively modest climate change scenario. Canada kind of falls here, where on average, I guess we're predicting about a 10% increase in precipitation. Some concerning ones would be smack there.
The Amazon.
The Amazon. The Amazon looks to be one of these areas that is moving towards a drying trend. And we're kind of seeing that in studies of tropical Amazonian forest ecology. We're starting to see trees, forests become more susceptible to fires. And there's other parts of the world as well, coastal regions in Australia. But again, this is kind of like a relatively modest scenario. If we assume our second scenario, this is then what the world starts to look like. We see much more stark patches of parts of the world becoming wetter. Some kind of counterintuitive, right? Like Saharan, Sub-Saharan Africa are actually expected to see some increases in precipitation, which, to the question before, oddly present themselves as prospectively good. However, we're starting to see other places, especially like the Mediterranean region, looking a lot more dry over by the end of the century. And then let's assume this happens, our most severe climate change scenario. And this is then what the world starts to look like in terms of precipitation change. And here you start to see, to highlight a couple things, is that you start to see the more extreme colors, either drier or wetter, becoming more and more prominent. And that is, under this climate change scenario then, probably really what this means is that every part of the world is going to experience some rather serious change in the amount of precipitation that falls in those areas. Some is going to be wetter, like the polar regions, the equatorial regions, and then some are going to be much, much drier as well, on the order of sort of, upwards of 50% reductions in precipitation. Some important regions like Central America, and again, the Mediterranean.
Canada fares very well.
What's that?
Canada fares very well.
I know. I'm going to show you some Niagara-on-the-Lake predictions that kind of zoom in on these maps, and I don't want to give the false impression. They look not so bad. Which, it's kind of like, I was talking with my wife about it, I was like, the analogy was it's like having the best house in the best room in a burning house. So this map here, these trajectories where some places are getting warmer and some places are getting wetter and some places are getting drier. You see this kind of like, you tend to fall into one camp or the other. The other thing, which we won't talk too much about, is that what we don't kind of know or are not presenting here is how this precipitation falls, right? It's not like a gradual kind of thing. A lot of this is going to come in the form of monster storms and sort of more extreme precipitation events. It's not like a gradual irrigation of the world that's going to happen. It's going to be coming in fits and starts. Yeah, Joanne, please.
Have you ever seen the worst case scenario with an overlay of agriculture, like where the food comes from and what is being produced in the area, in different areas?
That's a fantastic question. That's more in the area of like impacts. I'm sure it's out there. I haven't done it here, but you can kind of speculate, right? So here in Canada, kind of the breadbasket of North America looks like actually some average increase in precipitation. That can be a little misleading because some of that is coming as like flood events. Some can be winter precipitation. It's a little bit misleading. We get a lot of like soy and other products from parts of Brazil. So it's a big question. It's an excellent one though, is mapping, climate impacts onto crops. The IPCC has a huge section on it, almost like a full chapter. Yeah. What was I going to say? Oh yeah, okay. So some are getting warmer, some are getting drier. That's kind of why you tend to see this maybe conflicting line of thought coming out of this climate science. Earth's freshwater futures, extremes of both flood and drought. Those things don't seem like they necessarily go together right off the bat, but that's actually what the climate change predictions tell us is going to happen. Which one you experience, or if you experience one of these, just kind of depends where you live. And that's why, kind of coming back to these summaries, this is the language that the IPCC report uses to discuss the findings related to precipitation. Continued global warming is projected to further intensify the global water cycle, including its variability, monsoon precipitation, the severity of wet and dry events. What it's kind of just telling us is that whereas temperatures going up, precipitation can go down or up, but really what we know is it's going to become much more variable. That's the real take-home message from that science of precipitation predictions. Yeah, let's talk about this, and then just two last things to wrap up. What are the likely scenarios here for Niagara-on-the-Lake? It's kind of hard to say Niagara-on-the-Lake because these predictions happen at pretty big scales. It's you can kind of think about this like, it's almost impossible to predict the future climate in your own backyard. And that kind of summarizes the difficulty. They call it downscaling. We can get it at the globe, and now we have to sort of break it down to smaller and smaller chunks. And that kind of becomes a little bit more tricky. However, for the scale of like the Niagara region, we can get pretty good predictions. And we could probably get some broad scale idea about what the climate's going to look like in Niagara-on-the-Lake, depending what emissions scenario you pick. Why do I have that picture there? Let's skip that. Okay, this was the really handy thing that the IPCC did this year, which is really cool. This is a website. They've gotten a little bit more savvy at trying to make their data accessible to people. And so what they've done in the most recent assessment report is put together this thing called the IPCC Interactive Atlas. So you can take all of these climate predictions and kind of pick different parts of the world and look at what the world's going to look like in those parts of the Earth under different scenarios. And so we can do that, broadly speaking, for Niagara-on-the-Lake. This is, I think, can everybody see how it's starting to become pixelated? Yeah, what that is referring to is that when we predict climate into the future, we kind of chop up the world into a bunch of small squares. And those squares are actually pretty big. They're a couple of, I guess, I don't know the exact number, probably 10 kilometers squared, something like that. They're relatively big. This is kind of the resolution that we can make these predictions at. Anything less than this, in a way, kind of doesn't make sense. Because it's like how many trees are shading this area, or how close you might be to a pool, or who knows what. So this is kind of the scale when we say what the likely Niagara-on-the-Lake scenario is. This is kind of the scale that it's a little hard to get more specific at. But I've kind of highlighted it here. Is that about where we are? Yeah, that seems about right. I didn't have the exact one. I thought that was pretty good. So we're going to look at some temperature maps and precipitation maps that talk, again, near term, medium term, and long term for Niagara-on-the-Lake under a low emissions that cut all emissions right away scenario and a high emissions scenario. You can go through these. So this is what we're looking at here. We're going to start with the low emissions scenario in the near term. These maps look the same. Darker red means more warming. Here in Niagara-on-the-Lake, I guess we're at about here, about 1.5 degrees in the near term. By mid-century, probably start to look like that. And in the low emission scenario, this is probably where we end up at the end of this century if we're to cut all greenhouse gas emissions pretty much overnight. Now, the more realistic thing is the high emission scenario, though. Greenhouse gases keep going up. In the near term, Niagara-on-the-Lake is still just about the same as the world on average. By mid-century, it probably starts to look something like this. And by the end of the century, under a high emission scenario, these are what the climate predictions would look like for our particular region where the Niagara region, Niagara-on-the-Lake, starts to look something more like this, with some kind of average increase of on the order of 3, 4, 5 degrees Celsius more than what we were at in the past. And this is the kind of thing I was alluding to. There's some science that suggests the Niagara region's in a good spot in terms of climate change, but under these emission scenarios, kind of the world is in not such a great spot. And Niagara-on-the-Lake's no different. These are the precipitation predictions. So again, bluer colors indicate wetter environments. Brown colors are drier areas. This is what I was going to talk about. See all these slashes everywhere? Yeah, what those mean is that the predictions are uncertain. We have a lot of variability, and so anything that falls in these slashes is kind of like, okay, take it with a grain of salt. Anything outside of those slashes, we have just much better information and data to make more reliable predictions. Okay, so here's Niagara-on-the-Lake. Again, we're in the low emissions in the near term. This is low emissions at the middle of this century and low emissions in the long term. Actually, not a lot of change. Anyone want to guess why that is? Broad guess?
Higher temperatures, but not.
What's that, sorry? Oh.
No, I was just thinking higher temperatures, but not more precipitation.
Yes.
With higher, it's going to be drier.
Yeah, it tends to be, it's a little bit like pop geography quiz. It tends to be because of the modulating effect of the Great Lakes, right? Our climate systems are a little bit more defined by the Great Lakes and temperatures of the Great Lakes and that kind of thing. And as we alluded to, for the same reason the oceans warm faster, the oceans warm more slowly, the lakes warm more slowly as well. So we tend to have this kind of modulating effect, being smack in the middle of two of them. And this is kind of true. So here we go to long-term, Here we have long-term. Sorry, I'm confusing myself. I got this stupid pop-up on my computer. Okay, these are our high emission scenarios in the near term. Here we are here. These are our high emission scenarios in the middle term. And this is the high emission scenarios in the longer term. So only there do you start to see some predicted change in the amount of precipitation that we're going to get here. Again, at its surface, this might look kind of broadly appealing for things like crop production. But what we don't cover here in this discussion today is how these increases fall. And again, it's not like we're not predicting like a gradual sprinkling of water that's going to benefit everybody. Chances are these increases are going to look like more severe storm events scattered throughout the year. So it's not necessarily to be taken as a net positive or a great thing. It's a little more complex than that. And that's why I'm saying, actually, if you hate snow, it might be worth pointing out that actually, the long-term high emission scenarios would indicate that predictions of snowfall in the region are expected to go down over time as well.
Don't buy a ski lodge.
Don't buy ski, yeah, there you go. And that's what I put up here, is that when we look at those predictions for the Niagara-on-the-Lake experience, those are like the averages, just year over year. Those are really saying nothing about extreme events. This is a whole different beast that probably is a little hard to cover today. The prevalence of heat waves, extreme heat, massive storms, that kind of thing. Those are coming too. We have predictions of those. And those are the ones that are going to really pose bigger challenges for cities, economic activity, that kind of thing. Okay, so this is where I want to wrap. This is where, again, as I alluded to, I kind of bit off more than I could chew. Predictions on the impacts. This is, I think, what captures the attention of most in thinking about climate change. It's a little hard to summarize all of these, so I put it into my own framework here. This is my 2 cents in terms of thinking about climate change predictions or predictions of climate change impacts. So when we talk about climate change impacts, sorry, that wording's a little weird. I kind of put them into 4 groups. The first is likely impacts. These are ones that I think are well supported by scientific evidence, observations, and data. And this is, some examples of those. In the interest of time, I'll go through them pretty quickly. The one impact of these changes in climate would be increases in sea level. Kind of a similar looking graph. By the end of the century, we can expect anywhere from 0.5 to 1 meter of sea level rise globally. That's the oceans actually rising for 2 reasons. 1, glaciers are melting. And 2 is the oceans, as they warm, actually expand. There's thermal expansion. And for both of those reasons, things go up. There's also this. Let's leave that. And these impacts are captured in a whole bunch of different ways. This was an organization called Climate Central that did a really nice touch, sort of visualizing what that means. For here in the Niagara region, not being next to a coastal area, it's not an immediate concern, but different parts of the world that we may have visited or know are going to suffer the consequences of this. So this is the Lincoln Memorial in Washington and the Pentagon. This is present day. And if we use a scenario where the planet warms by 3 degrees, so that kind of middle of the road prediction, this is the expectation of sea level rise in those coastal regions in the United States. Or maybe the Pentagon underwater. Similarly, I've never been here before. Anybody been to the McMillan Space Center in Vancouver? This was the only Canadian example I could find. Vancouver is kind of, the one big coastal Canadian city that shows up in these graphs. And Statue of Liberty, present day, under a 3 degree Celsius warming with the changes in sea level rise that come along with it. This is what we think that's going to look like. And the last example, sort of an international flair, is the Sydney Opera House. This one surprised me, Buckingham Palace. I kind of didn't envision that as being susceptible to sea level rise, but these would be the predictions of what those are going to look like under a 3 degree Celsius warming scenario by virtue of sea level rise. So we have some good evidence, and this kind of stuff has pretty good science behind it, actually, because we go greenhouse gas emissions to temperature increases to sea level rise, and then you can use sort of different ways to predict those. Try and wrap up here. Sorry. Ocean acidification is another biggie that we have good evidence for. You've probably heard of coral bleaching in some form or another. That's most certainly has this likely scenario. We have a lot of good evidence on that. And then these things, which I don't have too much time for, heat waves, wildfires, crop failure, floods, as was alluded to. We have pretty good evidence that these things are going to unfold more commonly under a shifting climate. There's good scientific evidence. I would say these are quite likely scenarios. I threw this one in here as well. Climate change migration is starting to get a lot more data behind it. We're starting to see people moving in tremendous masses, tremendous distances away from shifting climates. This came from the World Bank just from last year, talking about a 10% rise in global migration. So we have some evidence that this is an impact that's actually happening. Okay, my next bin is this one. These are possible climate change impacts. I'd say these are supported by sort of reasonable scientific logic, but the evidence is kind of limited. I'll talk about this next month. Oddly, I would say biodiversity decline falls in this category. There's not a lot of evidence that things are going extinct because of climate change just yet. It's sort of starting to unfold, but it seems like it's more of a likely scenario, not a firm bit of evidence behind it just yet. That's next month's discussion. Senator, you were talking about, this was big too, likely. There's sort of qualitative evidence, observational evidence a little bit, that as things like permafrost start to melt, these old archives of microbial life are sort of springing back to life. And these can be good or bad, probably bad. There was actually an anthrax outbreak in one Russian community owing to permafrost melt. I'll go through these really fast. Financial instruments and markets are most certainly starting to change. Does anybody own property in Florida? By chance? I just heard this thing, because Hurricane Ian took such a toll that insurance companies are actually reevaluating their risk profiles in climate change prone regions. So there's certainly socioeconomic impacts. We alluded to mental health impacts. Do you want me to wrap up there, David? Oh, okay. Mental health impacts. This is sort of like an emerging theme in climate science, is this idea of climate change anxiety. Did you remember this from last year? A BC doctor diagnosed somebody with climate change. There's, I'm not sure of what the actual details of this were, but the climate change anxiety that they're, a young individual worried about the future of the planet in a debilitating kind of way. I don't know what the mechanism of that is. That's, I think, where the science is a little tricky. Okay, then there's this other group, which I'm calling curious. These are the who knows, but they're often interesting. These ones show up in different news reports in different ways. Beer seems to, it's kind of like, it's like a third tier effect of climate change that shows up here. This is kind of outrageous.
It could cost you more than a tank of gas.
Yeah, your next pint could cost more than a tank of gas. Like, okay, maybe, I doubt it, but whatever. It's kind of interesting. This was a whole article on the Bloody Mary and how the different Bloody Mary components are going to be influenced by climate change. There's some other ones there, they make for a nice headline and you're like, how is that actually going to work? This was about how climate change is going to ruin air travel. I guess that one actually kind of makes more sense. This one I'm a little less clear on how climate change is going to ruin your indoor air quality. It's a weird one. And these last two are, probably my favorite examples. There's a study that came out talking about how climate change is likely to trigger more earthquakes. And I can't for the life of me understand how that would work. And it's been noted as being a little bit shaky. So this is one of those impacts you're like, I'm not quite sure about that. And the last one, I just saw this today. New research suggests climate change will make our space trash problem even worse. And once again, I have no idea how that connection is there, but these are the kinds of things that you see associated with climate change. And then my last point here, when you think about the categories of predictions, I think it's worth noting that, there's a fair bit of different aspects of the sort of climate change denialism that still persist in media.
They're the anti-vaxxers.
What's that, sir?
They're the anti-vaxxers.
Yeah, there you go. And this is what I'm calling like speculation that tends to masquerade as science. Now there's interesting conversations like we just had, like, hey, is climate change actually presenting some benefits to different parts of the world? That I think is a valid conversation. But sometimes you see these popping up in more generalized forms like this, like why climate change is good for the world, where you see broad scale, broad stroke suggestions like crops are going to grow faster, polar bears are going to adapt to their new environments, and on and on and on. And I just want to highlight that, as we talked about last week, while the climate change debate has kind of faded, these types of things still do show up once in a while when talking about the impacts of climate change. And so, in sort of, just my 2 cents, if you come across news articles that are talking about the impacts of climate change, I always think trying to see if it fits into one of these bins is a good way to think about them. Is this likely? Is it well supported? Is it just kind of weird? Or is it possible? And think about which ones are really rigorous. And so that brings us to the end. That's our 6 points about what the future of climate will look like. I'm happy to take any questions, of course, but we might be running low. So thanks, everybody. Appreciate it.
Thank you.
Questions?
You still taking questions?
Oh, we can? Yeah, sure.
Take some questions, sure.
Yeah, please, Gordon.
Well, excellent presentation, and part of what you touched on were the very different impacts in different countries or different regions. And you made a great point that in the Arctic, that's essentially Canada, Russia, and the Scandinavian countries, that temperature temperatures are going to go up. And you can argue, for example, in the case of Canada, that for most of Canada, this is a good thing, because our winters will be much shorter, our possible areas of growth in agriculture may get bigger. Of course, northern communities are going to suffer, but that's a relatively small part of the Canadian population. You can argue that Canada, especially relative to other countries, is in a good position. But countries in the tropics, relatively poor countries, countries in general with increasing populations, big time, they're already hot, and they're getting hotter. So the difference between Canada, a cold country getting warmer, benefiting, compared to those tropical countries, poor countries, very difficult for them to adapt.
Yeah.
They're the ones who are really going to suffer. And, of course, that leads on to global migrations and so on.
Yeah. No, those are great points. I think the idea of hot parts of the world getting hotter, like, an area like, certain parts of India that experience 50-degree temperatures to begin with, or more recently. What does that look like if you go up by another 5 degrees? Much of which is going to be experienced as like pronounced heat events. I don't know, those are uncharted territories. And so just your last point, the global migration thing, again, I was chatting with my wife about this picture that the Niagara region kind of looks appealing, right? As more of a stable climate entity.
We don't need more tourists.
But there you go. I mean, that's the flip side. Like, what does that actually mean if you're living in the more appealing part of the world? To think, the migration, let's say the climate change migration phenomenon has kind of been experienced in the Mediterranean region, right? From Northern Africa to Europe. I think it would be naive to think that that's not going to start to play out in different ways throughout the world. And to your point, with Canada looking somewhat appealing, resource rich, all these things. It stands to reason, I think.
Jeffrey, what's the probabilities on these predictions that's being made? Is it high probability, low probability?
That's like the IPCC, like an IPCC scientist. The temperature ones are quite good. They're quite strong. I couldn't give you a number. That's where they use this language, high, very likely, low likely, usually when they say most certainly, that means they're 99% sure. I would suspect when they say very likely, they mean 95% sure, and then it kind of goes down from there. The temperature ones are really good. The precipitation one and the extreme event prediction, that's where it gets a little lower, but they're still strong. They're still reliable. They're still the best that are out there in the world.
Better than current weather forecasts.
Oh, yeah. Well, that's a great point. You can probably predict, the predictions of, at least near and medium term are better than weather forecasts 2-3 weeks.
Even though they may use the same models or something like that.
Well, yeah, it's a bit of a different beast. But, Joanne, please, you had your...
Well, just to add to your point, I was listening to a TED Talk the other day, and there are some social justice people that are saying that the floods in Pakistan, where millions and millions and millions of people are homeless, they think that the countries that are generating the fossil fuel should be paying for the damages, and so that becomes an issue as well.
That's a great point. I didn't allude, I can't help but flip back to this. I'm sorry, I need to show you this one. Yeah, you're right. This one here. This just happened this week. Countries in developing parts of the world that are getting hit worst by climate change are starting to consider, don't consider this, if a big flood happens, don't consider this aid. This is actually like climate change reparations. And so this just came out last week, is that developing nations are starting to threaten withholding international debt repayments unless there's actual action on climate change. So there's a lot of movement, through the International Monetary Fund, the World Bank, of just that. Developing nations starting to sort of rectify these imbalances.
Good.
Yeah, Terry.
I was just wondering how the global currents, water currents, how are they all being affected by?
Yeah, that's such a huge, complex question. The changes in water currents are kind of embedded in the bigger predictions, right? Predictions about how different parts of the world are warming, how different parts of the world are experiencing more or less precipitation. That's a complicated sliver of the overall climate models. They're changing a lot. I don't know it specifically offhand, but they're definitely changing. There's some currents that are switching directions. Yeah, they're changing. Yeah, Sandra, please.
I want to say something else, but just to follow on with the currents, I heard about the one that goes along Labrador.
Yeah.
That has changed significantly this weekend or whatever, I can't remember the details, but it's a significant change there.
Yeah.
I just wanted to mention to people, in case you're not aware, that the town last year adopted a climate change adaptation plan, along with Brock University helped us out with this, and Adam has seen it as well. And so we're looking at implementing it in the upcoming years, but it's on the town website if you are interested.
Thank you.
Yeah, thanks for pointing that out. I thought it was really nice, nicely laid out, and touched on all of the adaptation things that a good plan should touch on. Yeah, please.
It's suggested to me, but in a conversation I had with a Dutch scientist, that if the world all became vegetarian, we'd
Yeah.
have a huge reduction in our greenhouse
Yes.
gas, just for, well, in part because of what cattle do to contribute,
Yeah.
and also just by basically the amount of money it costs to raise,
Yeah.
Yeah.
you know, meat for the world to eat, right? And we're growing as a population, right?
Yeah.
So we have more food to eat.
Yeah.
So I was just curious, like, could we give you a homework assignment for the next lesson?
We all go vegan till next month.
Yeah, you can do it online. There's usually these carbon footprint calculators, and usually the first question is what your dietary preferences. There's some like age, blah, 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 but it's usually are you vegetarian or meat eater? And that's because agriculture is our main source of emissions, and within that, animal agriculture in particular is a huge chunk of it, like methane emissions and that stuff.
Yeah.
So quite honestly, the science is pretty clear. If you want to make household changes that reduce your own greenhouse gas emissions, the switch to a vegetarian diet is like the overnight switch. It's also why they, what's up?
Our own James Cameron, director, he created the Game Changers, a little documentary just about that. What would happen if we changed the vegan diet.
Yeah, and you know those huge greenhouse gas emission scenarios that climb up? Like a big part of that is, or at least a significant chunk, is increases in meat consumption, particularly in developing parts of the world, well, emerging economies like China, called the meatification of diets. Yeah.
Well, maybe just one last point about sea level rise. Of course, you're quite right that globally sea level is going up a little faster in some places than others. But there are places that are sinking, that are going down. And you talked about Buckingham Palace. Well, southern England is sinking. So you have a double whammy of sea levels rising and at the same time going down. And it's the same with, say, Halifax, which is in an unusual situation because most of Canada is rising and Canada's getting bigger. But there are places that are sinking, and that exaggerates the effect of sea level rise.
Double whammy. Yeah, I think the sea level rise, and then we can wrap, is the hardest thing to imagine. I think we can envision a hotter future. I think we can envision more storms. I think those climate things you can envision because you experience weather all the time. I think it's really hard to wrap your head around a world where the Statue of Liberty's half underwater, but the predictions are saying that's, you know, there's no reason to doubt certain aspects of these predictions now.
Well, wasn't there just recently a town in sea that has been severely flooded and they are buying out all the properties and having people relocate because they're not going to build this?
Oh yeah, that was the other one. In Indonesia, they built a new capital because they're Jakarta. I haven't seen this. Jakarta is basically looking like it's going to be underwater. So certainly parts of the world are planning for this in different ways. Yeah.
It's for years.
Yeah.
What news site was that article on the climate? Yeah.
This one?
Yeah.
The New Republic, which I must admit I'm not familiar with, TNR. It was on the the New Republic, which I'm not quite sure, I just was sort of headline scanning. But you can probably find a couple of headlines on this theme.
Okay.
It made news last week, so it was a concerted media release that came out from a number of countries. Yeah,
And Venice is secret.
yeah, there you go.
And also Hawaii.
Hawaii's in Yeah, I mean, this sea level rise issue is going to be,
Yeah.
I think we'll start to see it sooner rather than later. Okay, great, thanks everybody. Debbie, thank you very much, everyone. Thanks for coming.